Got it. Share my screen, start the broadcast. Okay. All right, so we're going to start here. You know, like we normally do. I'm trying to think, and I'll just monitor because I know it's kind of been on the fritz as far as like mirroring, and you know, I am monitoring, so you know, so far it looks good. Let me see this as far as announcements go. Okay, so let me pull up my calendar. So we're at the end of week. What is this? Week 14. Let me see. We've had our 3 exams. The school closes at noon on next Wednesday, but we're not gonna meet on next Wednesday. We will meet this upcoming Monday, right? So we're in the home stretch, right? So today we'll do as many homework questions associated with section 6.4 as we can together, and then after today we're only going to meet 3 more times. So this upcoming Monday we'll take that time to review exam 1. We're going to take that following Wednesday off for the Thanksgiving holiday, right? And then we'll come back the following Monday on the 28th. We'll work on exam 2. We'll review exam 2 in preparation for the final. And then on November 30th, that Wednesday, that's the last day of class, we'll work on exam 3 and the sections after exam 3 in preparation for the final. That Thursday and Friday, December 1st and the 2nd is a reading period. So you shouldn't be meeting in any of your classes on that Thursday and Friday. Hopefully you all have been collaborating with Dr. Lamar, the coordinator for the lab component, and you've been following her instructions, you know, so any questions about lab, you have to communicate with her because that's her domain, that's her thing. So we come back, and I want to say your final exam should become available that Sunday, December 4th at 11 a.m. And that's that Sunday before the week of finals. Finals week this is that first full week of December, which is going to be here in a blink of an eye. It's that the 5th through the 9th, right? So that Friday, December 9th at 11:59 p.m. is the hard deadline for all assignments, right? So the idea or the goal is when you submit your final exam, you should be done. That should be it. You know, you don't want to have anything lingering past the final. So now is the time to go ahead and get whatever it is that you want on Pearson, whatever grades you want, 90% or less, just go ahead and get them submitted. Yeah, now is the time. And if you're going back and complete old assignments to improve your overall grade, then you obviously you want to prioritize your exams as they count for nearly 80% of your overall grade. The last thing that you want to prioritize is the homework. The homework is going to be a whole lot of work for little minimal points, right? So you might do a lot of work in the homework, but you're not going to see a shift in your grade. If you want to see a shift in your grade, prioritize the old exams. I think that's it. I can't think of any other pertinent information. Let me take this time to just check on you guys in Zoom one more time for any latecomers. Let's get them. I think I got them. Go here. I do want to try to figure out, but this doesn't concern you all unless I implement it. But during the week of finals, what I'm thinking is, at a minimum, I'll try to be online at least like during our regular class time. So if you need to reach me or if you have questions, you know how to reach me. I'll do the best that I can. You're not obligated to attend during the week of finals. You just need to submit your final and then that's it. But I'll make myself available. I'll just try to be online. That's not a guarantee, but I'll try, right, during the week of finals. Okay. As always, if you have questions, feel free to unmute yourself to get my attention or type in the chat, but unmuting yourself is the recommendation as you get a faster response. So let's take some time to go through as many of the homework questions together as we can. This comes from section 6.4, systems of equations in two variables. It says, which of the ordered pairs is a solution of the given system, right? In order to be a solution, when you plug in the x and the y, it needs to make both equations true. All right, so if we try 0, -1, it makes the first equation true and the second equation true. So I'm just going to go with that. I'm just going to go with that one, right? Because it made, when I plugged that one in, it made both equations true. Okay, next question. Determine which of the ordered pairs are solutions of the system. Now, we could just plug and chug, right? There's nothing wrong with that. They gave us a list of solutions. I think I'm just going to solve this one. Does anybody have like a request? Because there are two main techniques that we have for solving a system of equations, either the elimination method or the substitution method. I think I'm going to do the elimination. That's the one I'm kind of feeling with this one. So, I mean, we could just plug and chug, but I personally would just rather just solve the system and then choose the correct result. Okay. So we're going to take this. Right here. Come on. Oh, wait. Come on. Oh no. Oh, you did the thing I was trying to do. You little thing. Okay, recently is this one. I think it's this one. That looks good, right? Yeah, I think that's the one. This device is like, I think it's just time to get a new device. I'll get one sooner or later. All right. It's just like a really temper. It's actually a really good device. You know, I mean, so far Apple's been treating me right. Like they've been doing a good job. Whatever they're doing, they kind of need to keep it going. Just don't. Sometimes they change, and it's just like they'll be making changes for worse. Okay, so let's just solve this system, right? So we got 5x minus 3y equals 7. We also have negative 10x plus 4y equals 11, right? This is what we're working with. So if I'm going to use elimination method, I feel like it would be easiest to eliminate the x because you can multiply any row by any non-zero number, right? The goal is you want these two coefficients to be the same with opposite signs. So it looks like we can multiply the first row by 2, multiply each term by 2, and then add the equations together, right? So then if we do this, we'll get 10x minus 6y equals 14. And then the second equation just comes down, negative 10x plus 4y equals 11. Now, notice we have the x's where they have the same coefficient with opposite signs. So now we can add those together. When we add the two equations together, a number plus its opposite, these add to 0. Negative 6 plus 4 is going to be negative 2y. 24, 25, right? 25. So then y equals a negative 25 over 2, okay? So we got this result for y. So then I'm going to plug this into equation 2. Okay. So then that means we're going to have negative 10x plus 4 times negative 25 over 2 equals 11. Negative 10x, let me see, that's negative 50 equals 11. Add 50 to both sides. Negative 10x equals 30, no. 61, right? 61. So 6.1. I'm gonna leave it as negative 61 over 10 for now. Okay. And we'll just have to adjust. It might show as like negative 12.5 and negative 6.1. 12.5 and 6.1. Maybe, maybe none of these? None of these, right? See, well, you know, if we had plugged in, we would have been guessing and checking and none of them should have worked, but we got that none of these are the solution. Now, we didn't check it. We probably should have checked it, but I got that none of these, right? So the solution we got was not in this list, so then none of those were the solution. Right? Let me check on you guys in Zoom. Ooh, man, getting older is fun. Okay, you guys look good there. Yeah, I'm gonna let that ride, actually. Yeah, everything is due December 9th. My exams are. Now, I think, you know, it's going to be different in your other classes, but everything for me, that means the final old assignments, everything locks out Friday, December 9th at 11:59 p.m. That's a good question. right? I'd rather you ask questions instead of assuming, because assuming basically makes an ass out of you and me, right? Solve the system of equations by graphing. Okay. Let's click to enlarge. So notice that the highest exponent on any variable is a 1. So these are both just lines. So I'm going to click on my line tool. All right, we're going to have to click and drag. So when x is 0, let me see if I add and subtract. The y-intercept there is -4. I'm just going to click on 2 points. And I'm going to click another 2 points. I'm just clicking on 2 random points, right? I'm going to drag them later. So now, with that first equation, you know, if I add and subtract, the y-intercept is -4. So I'm going to drag this to -4, add and subtract, and the slope is 1. So then if we go up 1 over 1, we're at 1, -3. So the second point needs to be 1, -3, right? So that's the first line. The second one, if we solve for y, we get -x plus 14. So the y-intercept is 14. All right, so I'm just dragging this point to 14. And then the slope is -1. So if we go down 1 and over 1, we should be at 113. See? So I'm using the upper right hand. No, it should have allowed us to type, but this is fine. Right, so now we can see they cross. It looks like it's what, 9, 5. 9 minus 5 is 4. 9 plus 5 is 14, right? So we're going to hit save. We've graphed those two. We're going to check the result, okay? And the order pair we got was 9, 5. Turn this off. The order pair, 9, 5. Of course, we got to be in the box. Come on. Parentheses, 9, 5. Again, if anything is not clear, feel free to unmute yourself to ask questions, right? A closed mouth doesn't get fed. Really, whoever does the most talking does the most learning. So as long as I'm the one doing all the talking, I'm doing the most learning. That's why I know it so well, because I talk about it so much. I wouldn't say every day, but at least when I'm with you guys, I try to talk about it. And that's been going on for at least a decade. So I'm not even really thinking about it at this point. Totally stuffing grapes in my mouth. All right. Estimate the solution by using the graphical method. So they're basically asking us to graph. Fortunately, the second equation is already in the slope-intercept form. I'm going to do the same thing I did before. We'll just plot them and then drag the points. So now, from the first equation, if we solve for y, the y-intercept is 6. So I'm going to drag this to the y-intercept of 6, like that. And then the slope is -2 if you solve for y. So then that means we should go down 2 and right 1. So we should be at 1, 4. So this next point needs to go to 1, 4, like that. All right, that's that graph. This one, the y-intercept is 6. Uh-oh. Are these the same line? They might be the same. Let's see. They are the same. Why did they do that? All right, 1, 4, right? Okay, we're gonna hit save. That's fine. Yeah, they're exactly the same. So we're gonna check. Okay. So then there are infinitely many solutions, and they're going to take on the form, for any x that you choose, y is going to take on the form -2x plus 6. -2x plus 6. Okay. Let me check on you guys in Zoom. Now, I know he was here because I was looking for him earlier. No, never mind. That was a different student. That's fine. Yeah, that's okay. All right, let's keep the party going. Next question. Determine whether the system is consistent or inconsistent. If it is consistent, determine whether the equations are dependent or independent. Do not solve the system. Okay. So inconsistent means the lines are parallel with different y-intercepts, right? These lines are not parallel, so they should cross. And then in order for them to be dependent, one would have to be a multiple of the other, right? So one is not a multiple of the other. So they are the system is consistent and the equations are independent. Okay, if I need to run through that again, just request it, okay? Let's do another one. Same thing here, right? Same deal. Okay, in order for them to be inconsistent, they have to be parallel. They have to have the same slope. We could solve for y. I know there's a way you could jump straight to the slope. I'm actually going to click on it because I'm trying to do it without solving. I want to click on view an example, right, and see what they say. Now, obviously, we could solve for y and compare the slopes. I just want to see if they do that. Okay, so they're graphing it. Okay, that's fine. Let me see. If I subtract and divide, the slope will be a negative 3/5 for that one. If I subtract and divide, negative, they have the same slope, and 15, 24 divided by 15. They're both divisible by what, 3? 8/5? I think one is a multiple of the other, right? We can multiply equation 1 by 3. We would get 9, 15, and 24. So because one equation is a multiple of the other, the system is consistent and the equations are dependent. Okay, because one equation is a multiple of the other, system is consistent and dependent. Okay, let's look at this one. Because I think they have the same slope, right? But they have different y-intercepts. I'm going to go on a hunch, right? Because like they're almost a multiple, right? If you multiply equation 1 by 2, you almost get equation 2, right? Because you'll get your 8, your negative 10, but then 9 times 2 is 18. So that means, I'm thinking that means that they're parallel, but they have different y-intercepts, so it should be inconsistent. I'm going to go with inconsistent. Okay. Next question. Solve the system of equations by the substitution method. Okay, they already gave us y, so then we plug that in and then check it. Okay, let me get a copy of this and we'll take some notes. Actually, I'm not going to get a copy. What I would like to use my trusted Dusty Rusty. Come on, this guy. No, this one. Yeah, good. Reload and refresh. Okay. I know there's a better way to do it I'm going to do, but I'm trying to think. Yeah, I was trying to just jump straight to the answer, but I might need to just write it out. Because essentially what's going on, I'm going to take some notes here, right? If we replace y with equation 2, we're going to have 7x minus 4 times 8x plus 73, okay, equals a negative 42, okay? I guess we should write it out. I'm making it more complicated than it needs to be. Let's just let's write this out. Let's take some notes. So I don't need this one right just yet. We can get rid of. No. I'm trying to get rid of this. I'm gonna let that ride for right now. Actually, let's go like. That's pretty good. Let's get a copy. All right. So then what I was trying to do before, I noticed a new feature, like they keep doing these updates and I noticed something as I'm gonna hit done and then I want to copy and delete. All right. So I think I now have a copy of it. So then now I can paste that copy here. Paste image. Notability, yes. Allow the paste. Yay, it worked. Nice. Oh no, where'd it go? Undo. Come on. Are you undoing my work? Let me just paste it again. Paste image. Okay. There we go. All right. Okay. Let me see the time. Time flies when you're having fun. And if time's not flying, you better start having some fun. Okay. Solve the following system of equations. Okay, substitution, right? So if we replace y in equation 1 with the y from equation 2, we'll get 7x, come on. 7x minus 4 times y, but we're replacing y with 8x plus 73. Okay, that should equal a negative 42. Okay. So then we can distribute. We get 7x, what is that, negative 32? 280 plus 12 is 292. Okay. If that were 10, 10, 20, 22, 25. Okay. So we get negative 25x equals, it ends in a 0, 5, 250. So then x equals, it looks like it's a negative 10. Okay. So then if x is negative 10, then that means that y is going to be equal to 8 times negative 10 plus 73, negative 80 plus 73, negative 7. So then our claim is that the solution is negative 10, negative 7. All right. Hey Siri, what's 7 times negative 10 minus 4 times negative 7?
7 times negative 10 minus 4 times negative 7 is negative 42.
Hey Siri, what's 8 times negative 10 plus 73?
8 times negative 10 plus 73 is negative 7.
Okay. So negative 10 and negative 7. Let's get rid of all of this. Parentheses, negative 10, comma, negative 7. Oof. Oh, all right, let me see the time. We got a solid 10 minutes. Let's try to get a few more in there. Substitution. Okay, looks like it's easy to, let's just go ahead and take a screenshot and take some notes. Take it from there to here. Here. I'm gonna hit done, copy and delete. Yay, so not like having all these useless photos that I'm not gonna use. Just wanna paste, allow the paste, cool. Because I'm really just using it just for right now. All right. Solve the system. Okay. So it looks like it'll be easiest to solve for y in equation 1. So what we add and add. So then we get that y equals x plus 3. Okay. So then we can take this and plug it in equation 2. We'll have 6x plus 2 times x plus 3 equals a negative 42. 6x plus 2x plus 6 equals a negative 42. 8x equals negative 48. X equals what, negative 6? Okay. So then our y y is going to be equal to negative 6 plus 3, which is negative 3. Okay. So we got negative 6, negative 3. Okay, I'm just going to submit this just for the sake of time without checking it. Negative 6, negative 3. Negative 6, negative 3. Nope. 6. All right, let's do another one. Substitution. Okay, let's keep it going. Done. Copy and delete. Paste. Allow the paste. Come on. Come on. There we go. All right. Just have to have it with my image. Can you guys see my screen? Okay, I think we're good. Yeah. Okay. Let's see. Substitution, right? Okay. So it looks like it's easiest to solve for y in the first equation. So from the first equation, we get that y equals 4x minus 9 times 2. Oh, this should be no solution, right? Because notice if we multiply the first equation by 2, we'll get 8. We'll get our negative 2, but we don't get 10. So when that happens, it should be no solution. This should be basically parallel lines with different y-intercepts. So it should be no solution. Empty set. Okay. Substitution. Let's see. Okay, this is nonlinear. Let's do it. Let's give it a go. The wrong thing. You can just delete that one. Delete the screenshot. Come on. Let's try to. And my device is totally being temperamental. Let's try this one more time. Okay. Like that. Go to there. Done. Copy and delete. Right here. Let's just paste. Allow the paste. Thank you. This will be the last one for the day. Okay. Substitution, right? Okay, so if we're going to do substitution, it looks like it's easiest to solve for y in equation 1. So from equation 1, we get that y equals x minus 1, okay? So then if we plug this into equation 2, we're going to get x squared minus x times x minus 1 minus x minus 1 quantity squared equals negative 19. So what I'm going to do here is just expand it all the way out. All right, expand everything that I can. Namely, I'm going to distribute this guy and I'm going to FOIL. First, outer, inner, last, right? So if we expand this out, we'll get x squared minus x squared plus x minus, we're going to have x squared minus 2x plus 1 equals negative 19. Okay, we got some cancellation. A number plus its opposite adds to 0. We also need to distribute this negative, okay, and then combine like terms. So then we get x comes down, negative x squared plus 2x minus 1 equals negative 19. Let's see. If we keep going, combine like terms, negative x squared plus 3x minus 1 equals negative 19. I'm going to multiply both sides by negative 1 just to make my, actually, I'm going to set it to 0. I guess the simple thing is just to, essentially what I'm doing is moving everything to the right side of the equal sign, but I'm going to write it like this. So let me see, that's going to become x squared minus 3x. So I added, I subtracted, I add, I'll get minus 18 equals 0. So again, what I did there, I moved everything to the right-hand side, but if 0 equals the right-hand side, you can reverse that and you'll get the right-hand side equals 0, and it's the same thing, right? Okay, so then here, let's see, we should be able, let's see if we can factor, right? So, you know, as long as you're doing math, you don't really get away from factoring. That's why we have the lab component to try to strengthen those kind of tool sets. I personally acknowledge that, you know, obviously, if you're not in the sciences or a mathematician, you're not going to be factoring, but, you know, as long as you're doing math, this is something that you need to know. So then the second minus, this guy tells me my two signs are opposite. So one is plus and one is minus. This one tells me my larger number is negative. I'm looking for two numbers that multiply to give me negative 18 and add to give me 3. I think it's 6 and 3. So let's go negative 6 and a positive 3. Okay. So then from here, we get the x equals negative 3 and 6. We got two solutions that we need to find the corresponding y for. Now, again, earlier we said that y equals x minus 1. So then when x is negative 3, y is going to be what? Negative 4. When x is 6, y is going to be 5, right? So we got, we got two ordered pair. We got negative 3 comma negative 4. We also got 6 comma 5, okay? All right, just for the sake of time, I'm just going to submit these without checking, but normally we would check this, okay? Just because I'm trying to get you guys out. Negative 3 comma negative 4 and 6 comma 5. Parentheses, negative 3 comma negative 4, and then comma 6 comma 5. Okay. Do you guys have any, are there any questions? Do you guys have any questions for me? Okay. Oh, no. Delete. Come on. Okay. So let me go ahead and make a copy of anything that you saw me writing. I'll make a copy of it available. That looks good. Send it in the box. When this bar finishes loading, you'll receive a copy of anything that you saw me writing. And if there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, enjoy your weekend. Take care, guys. Peace.